Now for us is to discuss what we were calling the four characteristics of the mean. Again, four things we know about how the mean behaves. And so I just gave it some simple data here to play around with as we need it. So this is not a frequency distribution table, right? There's no frequency column. There's just 5 scores here, 5, 4, 3, 2, and 1. So 5 plus 4 plus 3 plus 2 plus 1 divided by 5 equals 3. So our sample mean, I'm calling this a sample mean. Again, it wouldn't matter. We could call it population, just change that to a mu, but sample mean is 3. So let's talk about the four characteristics. The first thing is about what happens to the mean if we change a score. So if I go into this data and I change any one of these numbers, if I change that 5 to a 6, if I change that 2 to a 1, if I change that 4 to a 4.5, if I change the value of any one of these numbers, the question is, will the mean change? Yes, it will always change. If you change any of these numbers, you will end up changing the summation of those raw scores, and therefore when you divide it, the answer will be different. So this one's a real straightforward one. If you change any score in your data, the mean will also change. It might change a little, it might change a lot. It depends on how many scores you have and how big of a change you make. But the mean will change, and it will always change. That will always be true. So next characteristic says what happens to the mean if we either add a new score, or if we remove an existing score. So I've got a set of 5 scores here. If I add a 6th score, or if I remove a score, if I erase one of these scores, what would happen to the mean? Will it change? The answer is usually, but not always. Usually, but not always. It's easy to see why it would change. If I add a 7 to this list, the mean clearly is going to change because, again, I've changed both the summation of the raw scores and the number of the raw scores. So we're going to end up with a score higher than 3 as our mean for sure if I put a 7 in there. If I come in here and I delete the 1, well, now I've only got 4 scores left. The summation of scores has changed. That mean, again, will change. It will go up by deleting a low score. So it will usually change, but not always. So let's see, why wouldn't it change? The mean will not change if the score we're adding equals the mean. Likewise, the mean will not change if the score we're deleting equals the mean. So in other words, if I put another 3 on this list, so it goes 5, 4, 3, 3, 2, 1, and I add up those 6 scores and divide by 6, I'm still going to get a 3. Go ahead and check it. Let's look at it another way. Kind of a mix between a scale and a modified histogram here. So let's think about it as a scale. Let's say I've got a scale here. And this is exactly where it balances out there. There's our fulcrum. So there's our 5 raw scores on a scale, and it balances right at 3. That's our central tendency. It's right there in that center balance point. Well, think about it. If this is really literally a scale and I add another score of 3, I'm just putting a block right on the center. It's not going to tip left or right. It's going to stay perfectly centered. If I add a score that equals the mean is 3, the score I've added is 3, the mean doesn't change. Likewise, if I go the other way, instead of adding a 3, if I delete the 3, the balance point is not going to change because the score I'm taking out is the mean, and therefore the balance doesn't change. So if I add a new score in, or I take an old score out, the mean usually changes, but not always. If the score I'm putting in equals the mean, there's no change. If the score I'm pulling out equals the mean, there's no change. So that is the second characteristic of the mean, that if we add in a score or remove a score, it will usually change, but not always. Our third characteristic is a little bit different, but similar to the second one. So number 2 is what if I put a new score in or take an old score out? Number 3 here is what if I add a constant value to all the scores? If I pick a constant, let's say 10, and I add 10 points to every score, got to do to all of them, what happens to the mean? Or the flip side of that, what if I subtract a constant value? They're both the same. So let's do it with the addition. So let's say I add 10 points to every score in the mean. Well, if I change every single score, we know the mean is going to change, but it's going to change in a very predictable way. Let's think about it like this. So I'm going to add 10 points to every score. So my 5 becomes a 15, my 4 becomes a 14, 13, 12, 11. What's the mean for this data? 15 plus 14 plus 13 plus 12 plus 11 divided by 5 is 13. I added 10 points to every score. The mean went up by 10 points. If I subtracted 10 points from every score, the mean goes down by 10. If I add 1,000,000 points to every score, the mean goes up by 1,000,000. If I subtract 1,000 points from every score, the mean goes down by 1,000. Whatever you add to every score, the mean goes up by that amount. Whatever you subtract from every score, the mean goes down by that amount. That's a predictable, known thing about how the mean is going to work. So that's number 3, adding or subtracting a constant value to every single score. The last one is exactly like number 3, but it's about multiplying and dividing. So again, if I multiply all the scores by a constant, or I divide all the scores by a constant, will the mean change? Yes. Will it always change? Yes. And by how much? It's predictable. So let's just say we're going to double things. I'm just going to multiply everything by 2. So 5 times 2 is 10, 4 times 2 is 8, 3 times 2 is 6, 2 times 2 is 4, 1 times 2 is 2. 10 plus 8 plus 6 plus 4 plus 2 divided by 5 is 6. It works exactly like number 3 above it. Whatever you do to every score happens to the mean as well. If you multiply every score by 2, the mean gets doubled. If you divide every score by 10, the mean gets divided by 10. It's just a known way we know the mean works. This last one in particular is used very often in the real world when we're switching scales. Let's say I was measuring things in minutes, but I want to turn it into seconds. Well, to turn a minute into a second, you multiply it by 60, right? Well, you don't have to go back and change every raw score. Just multiply the mean by 60, and you now know what the mean is in seconds. So when you're converting from minutes to seconds, or feet to inches, or whatever it is, Fahrenheit to Celsius, when you make that conversion to every raw score, the mean gets converted the same way. So you don't have to go back and change every score. You can just change the mean and know what it is. So next up, we're going to talk about how we can apply some of this to some different sorts of problems.